All right, mean value theorem for derivatives. What is it you really got to know? Okay, first of all, in order to do one of these problems, you have to have a function that's differentiable between a and b, which I have here. What do I mean by differentiable? It has to be smooth and no sharp edges and no breaks or anything like that. And it's got to be continuous on the closed interval ab. So basically, it's got to be connected as you draw from a to b. You got to be able to connect the line, okay? Now, this is not a mathematical definition. This is sort of like the intuition behind what it says, okay? Now, here's what it means. This blue thing that I have written right here, all right, that's literally just the slope of the line that passes through those 2 points. That's called the average rate of change, all right? This part is f of b minus f of a. This part is b minus a. It's just rise over run. It's just a fancy way to write the slope. Now that means, then beyond that, that means what the mean value theorem says at this point right here, roughly, I'm just sketching this, there's some C value, and it's super important that it's between A and B. It can't be A and it can't be B, but if I drew a tangent line there, the tangent line would be parallel to that secant line, okay? That's what the mean value theorem says. Those are the kinds of problems that they're going to want you to do on something like an AP exam. So let's actually do one. Okay. Here's the problem. Consider a function x cubed minus x. Find all the values c that satisfy the conclusion for the mean value theorem for f of x on the interval -1 to 2. So, pause the video and look at the blue part. That's me calculating the average rate of change. That's there. Okay? Now, then I took the derivative, and I got 3x squared minus 1, and I set it equal to 2, because I want the derivative to be the instantaneous rate of change, which is the derivative, has to be equal to the average rate of change, right? And then I plugged c in for f prime, so that's how I got this right here, and then I solved it, and I got 2 answers, 1 and -1. So you might be tempted to say that your answers, the function's going to have derivatives that are equal to 2 at 1 or -1, and they are, but the mean value theorem says it can't be on either endpoint, so you have to exclude this one. Now let's look at a picture for some more insight. Here's that function. Now if I connect, remember it's on the interval -1 to 2, so if I draw that line in, it would go from here to there, right? Now if I drew the 2 tangent lines in, I'll do those in blue. At -1, yeah, the tangent line would lie right on that line, and at 1 it looks pretty good too. But we have to exclude the one at -1 because it's on the endpoint.